Woohoo! Okay, this is the Huff Hackathon, Pre-Hackathon workshop with Jtriley.
What's
And
going on, guys? So, we're just gonna basically go like start to finish real quick. How to actually use Huff within Foundry. Part of this is because there's a few different libraries out there that do this like Huff integration with Foundry in slightly different ways. Some of them do some like unnecessary contract deployments if you actually put it into production. Some of them don't. Each one makes their own trade-offs, of course, but we're gonna do a pretty like minimalist, bare bones type of deal. So, first thing we're gonna do is we're gonna do our forge init. By the way, if the screen's too small or anything like that, just let me know. I'm gonna open up VS Code here in a second, so I'll just make everything all big and bulky. But we're just gonna go ahead and create a new Foundry project. Let's call it Huff integration because why not? Or let's call it Huffy because it's Huff FFI, right? Better name. Okay, we do our initialization. And let's pop up in VS Code real quick. All right, take your time. This guy likes to take a crazy long time to load sometimes.
could you bump up the size maybe 2 notches?
Gotcha. One sec. All right, there we go. That look better?
It could probably even go for one more, to be honest, because there's some kind of lag or something. Okay, yeah. It was making it a little bit blurry. So yeah, this is perfect.
Cool, cool. Yeah, geez, this thing. It's so slow sometimes. It's like so this is actually like my first like dev machine from back in the day. It's an old like M1 Mac, whenever M1 Macs were like the hot new thing. And yeah, it oh, hold on. Let me. So, by the way, we're gonna rename these really quick, just to like, I don't know, Puff stuff, just so we can kind of like give the stuff a look, try it out, stuff like that. But yeah, this was actually my first dev machine. So like all of the stuff that's been like set up on this thing was back whenever I had no idea how computers worked, and it was just it's all a mess, and I just never got around to fixing it. But this is actually like an emulated version of VS Code, and so it's gonna run a little bit slow sometimes because back then, it was like only for it was only for like x86, and they had to do this like emulated like transpiling thing. I mean, it was a mess.
One
But
question though: how
so
do you deal with all the smoke coming out of your machine?
yeah, well, surprisingly, this one is actually like the lesser of the evils here. Like I got a ThinkPad as well, and man, that thing puts off some heat. But this little thing, it's the little like M1 like Air. It doesn't even have a fan in it. It very very rarely overheats. Now there was one Solidity extension that managed to overheat it one time. There was some kind of bug in it or something, and it just ate up like all of the CPU. It was crazy, but other than that, pretty solid machine, not gonna lie. I do miss my framework though. That framework's a pretty sweet laptop for doing this kind of dev work. So real quick, we're gonna jump into the Foundry docs and just take a look at FFI. So FFI, for those who don't know, it's I think it's foreign function interface. Essentially, what this thing is it allows you to interact with like your shell or like your like Bash or like ZSH shell, and like call commands on that from inside of Foundry, right? So this is actually like, maybe don't run untrusted code with this, but for your own purposes, right? Like it's something that's pretty useful here. So what this thing does is a little function. It's on the VM interface. If you're familiar with Foundry, it's that like custom VM address, and then it takes an array of strings and it returns some bytes data, right? And so we can see some examples in here, right? Like doing echo and things like that, right? So we're basically just going to use like this style of thing. So let's just do we'll call it a library called Huff stuff. Okay, and so we're going to need a couple of functions here, right? First, we're going to need a compile thing. We should probably just go ahead and get the file path. as like an argument, right? And we'll just call this internal. I don't think it's going to be pure, but I do think it's going to return bytes memory, right? So what this thing is going to do is it's going to take the file path of a Huff contract and it's going to return the compiled, the compiled Huff code, right? And then one other thing we're going to do is deploy. Now this one's going to get a little saucy because there's not really a way to deploy like raw byte data in high-level Solidity. You have to drop down into assembly. There's pretty much no way to avoid that. So we'll also check out the Yule docs on this one. And again, if anybody has any questions that are unrelated to this or related to this, just feel free to drop those in the comments. Here, right? That's going to be value, pointer, and length. I don't really like these names, but essentially what it is like the value is the amount of ether that you attach with the creation of a contract. The pointer is where the bytecode starts in memory, and then the length is how long that bytecode is in memory, right? So really quick, something I want to do just to make sure that we're all on the same page with this is we're going to open up Chisel. By the way, you don't have to do this on your machine if you're following along. This is just for the sake of like showing you what's going on. By the way, for those that aren't familiar, Chisel is like a Solidity REPL. It allows you to just kind of like play around with like random Solidity stuff. This is like the perfect fuck around find out machine if you're ever not sure how something works. So let's just do something. Let's call it data, right? And we'll just make it like A, B, C, D, C, C, D, D, right? Something really simple like that, right? And so if we hit data here, we see what it is, right? We have a length of 4, and then we have those 4 bytes, right? And so if we drop down into assembly, actually, what's going to be the best way to do this? Yeah, actually, all right, so let's do MD. So memory dump is just like a raw dump of like what memory looks like, right? And so in Solidity, where are you? Layout and memory. So in Solidity, you can hop over to this page here, and you get 64 bytes of scratch space, right? That's going to be these two guys here. These are in 32-byte chunks. So these things right now, they're 0 because nothing's been hashed. But this kind of stuff, you can really just expect it to be just like random values throughout. Don't ever depend on like those values staying the same. So after that, you get another 32 bytes that points to the free memory. So if you ever see somebody in an assembly block do mload 0x40, that's what they're doing is they're loading this value, right? And this thing points to the next chunk of memory that has not been allocated, right? And if we look at CO, right, this is AO to CO, right? So the next slot after this is where free memory is. After that, the next 32 bytes are the 0 slot. This thing has to stay 0 all the time. You'll see some people that drop down into assembly abuse this a little bit, but they always reset this back to 0, because if you don't, you get some crazy undefined behavior. This has to do with the way that Solidity allocates memory for arrays and things like that. I'm not going to go too much in depth. The point is, these 4 slots pretty much always going to be the same thing. But since there's only one memory value that's been allocated, right, that's going to be this bytes data, we got 2 different slots here, right? We got 4, which is our length, and then we get our bytes data, which is here, right? So if we go and let's say like UNT256, we want to get the length. We can go into assembly, and whenever we mload data, right, this is loading whatever this value is, right? So if we look at that, whoops, hold on, forgot to assign. Len equals mload data, right? And so now if we look at what the length is, 4, perfect, easy peasy, right? Now the reason I'm going crazy in depth on this is because if you want to, let's say let's get like bytes 32 raw data, just for the sake of like seeing what the other part looks like, right? If we do raw data equals mload, and we're actually going to add 32, right? Because 32 bytes to data, you'll see the raw data is these little like 4 bytes here, right? So this is important because if you want to actually look at the bytes themselves, you have to start at this 32 byte offset. Otherwise, you're going to start at the length, and you don't want that whenever you're doing contract creation, right? Now, all of that is to say, we take this bytecode memory thing, right? We have an address. We're just going to call it deployment, right? And what we're going to do in here is we're going to drop into assembly. And we want to make the deployment equal, I mean, well, this thing is pretty much already picked up on it. We're still going to type it out anyway. So we have the create opcode, right? The value is going to be 0. The next thing that we're going to do is, what is it? One sec. All right, the next is going to be the pointer. So where the bytecode actually starts. Now remember, it doesn't start at bytecode. It starts at bytecode plus 32. And then last thing is going to be length, right? And we know that the length sits at the bytecode. So we mload bytecode to get the length. We add 32 to bytecode to get the pointer. And then we create with 0 value, right? So this does the contract creation. This runs the initialization code, yada, yada. And we want to make sure that deployment is not the 0 address, because if creation fails, that alone does not bomb the transaction. That actually like continues execution and it just makes the address 0. So we want to make sure that the deployment did happen successfully by doing a little require statement there. And because Solidity is Solidity, we can get an implicit return here. So we don't actually have to say like return deployment. It just returns that like implicitly, right? So that's our deployment. And then for our compilation, right, let's just take a glance back over at the FFI. And we have, okay, so we create a memory array, or sorry, a string array in memory, right? We need to put the command, any other like, flags, and then any other arguments, go after that, right? And then we want to do vm.ffi. So we'll do string array, call this like args, right? And then I think it's going to be 2. All right, so whenever we compile something, right, in Huff, we're going to say going to be Huff C, and I think we can just put in the path right after that. Let me just double check. Options, path, subcommand. Yeah, perfect. Okay, so we're going to have 2 of these, right? Now, the first arg is going to be Huff C, right, because that calls the Huff C command, and then the second is going to be that file path, right? After that, we do vm.ffi args, right? And so what this should return, which we'll get to this error in a second, but what this should return, if we look at the signature, is bytes memory. And so that's exactly what we're going to be trying to get out of this. So we'll just say return vm.ffi with the arguments, right? And so look in here, we say undeclared identifier. Now the reason for that is because VM is not declared locally. So we're going to need to import that, right? Now that comes from, I think we can just import this file directly. Let's see. Yeah, interface VM is VM safe. Okay, so VM is going to come from here. So we're just going to import that. I'm going to do a direct path, or like an absolute, not absolute, sorry, a relative path import, just because VS Code likes to yell at me for no reason. So that right there is going to point us straight to that path. We can verify that by right-clicking. And let's say just import VM from, right? Now in here, we're going to say VM, we can call it private. We don't need to expose that. Equals, right? And then, so the VM is actually an interface over an address, right? And that address is some crazy big number. Hold on. That might actually be defined in here somewhere. Let me see if it is. No. Okay, one sec. It is. I know it's in here somewhere. There we go. There it is. Okay, so that's. My God, what a monstrosity. All right, I think this should be what we're looking for. So let's just snag that real quick. Okay. Library cannot have non-constant. Oh, yeah. Private constant VM. Cool. All right. So that should be good to go. Let's just give it one more double check. We have a compile function that takes the string. That's the file path, right? We're going to go and run this vm.ffi command. Whatever we get back from that, we're going to return it. And then we can actually take that and we can do a deployment here. All right, so let's just give this a quick little test. We'll call it test.huff, right? And so let's just give it a quick little. Okay, OXO return. Yeah, that should be good to go. All right, so first thing we want to do is make sure that it compiles with the regular Huff compiler. It does. Oh, right, we need that bytecode flag. I think that's what we're looking for. Yep, okay. So we want 3 arguments. And the third one is going to be bytecode. Okay, so whenever we run this command, it's going to give us this. So let's go ahead and test this out. We'll go to forge test. Get rid of all that. We'll import Huff stuff. Okay, so we'll test if this works. So let's do Huff stuff dot compile is going to be the first one, and that's going to give us src test.huff. All right, so that's our Huff file. That's going to give us bytes memory. Let's call it a init code, right? And then we get deployment like this. And so from there, we'll just console log the deployment, just make sure it's like non-zero, right? I think console log should do that. Console 2. Let's see. All right. We'll give it a go. Now, first thing you'll notice is whenever you do this, and this is like a really, really important safety feature with all of this, but whenever you do forge test and you're doing something with FFI, you have to explicitly enable it, right? So it's going to tell you here, you either run it with FFI or you go into your foundry.toml file and enable that explicitly by just saying FFI equals true, right? That's a really, really important safety feature because if that wasn't like that, then like, yeah, you could kind of just like run arbitrary code on people's machines, and that's not good. So it looks like the test passed, so let's just go ahead and do this with more verbosity, and there we go, there's our address. So that's all we need to know. That's pretty much it. So this little thing here, I'm going to put it into, I'm going to put this into a little gist for you guys, and I'll drop that link down below. Stuff.sol. There we go. Cool. Also put the other files. Yeah. So I'll go ahead and put. Let's just call this Huff stuff test. Okay, so both of these should work with, wait, where did it go? One sec. There we go. Yep, so that should be good to go. You should be able to, just drop that straight into whatever you guys are running with, and you'll be able to just use that directly. So hopefully that was a bit insightful on how to do that. Obviously, like if things get like really weird and it's like really hard to reason about what's going on, you're gonna have to drop into the debugger. I won't go into that because that's like a whole hour-long thing. It's kind of crazy how much goes into that whole debugger thing. But yeah, and of course, if you guys have any questions, feel free to ping me throughout the course of the hackathon if you have any issues with this kind of stuff. Another thing to note about this one here is you can actually also use this in a Forge script, and that's not going to do any additional contract deployments. I think the original Huff deployer actually did do like an unnecessary contract deployment, just doing some like Foundry weirdness. But that one there doesn't do any unnecessary deployments. It's just going to compile that bytecode for you and then slap that thing onto the chain.
Awesome, man. You want to talk about any
Oh,
hackathon
yeah, so
details?
for the tools that were being used, so yeah, Chisel is that like REPL, that's like the command line thing that allows you to play around with Solidity. And then the main like development environment, right, that was just like a Foundry project, right, just running that in VS Code. But yeah, Chisel, I highly, highly recommend. If there's ever something that like you don't know how it works in Solidity and you want to see how it behaves, you can just like drop straight into that thing. It allows you to do a memory dump. It'll show you the state of memory, show you the state of stack. It's a really, really cool machine. So definitely worth giving that a look. Discuss hackathon project ideas. Yeah, totally. So let's see what all this stuff is. I actually haven't gone through every single one of these. Let's see. Deterministic address, contract back3 based on create 3. Create 3 is a combination of create 2 and create. Opcodes. Okay. Oh, this is weird. I actually haven't looked much into create 3, so I'll have to give that a look. But yeah, so pretty much like in terms of like hackathon projects, right? Like pretty much anything you can do in Solidity you can do in Huff. Obviously, like the really, really big stuff maybe isn't necessarily feasible for a weekend, but yeah, if there's anything that you've seen around, like you can also just kind of like pick that stuff apart and give it a try. You're pretty much guaranteed to get better gas efficiency out of the box because you're breaking a lot of abstractions away. Looking into some of these other ones, so there are some. Let's see, elliptic curve libraries, right? So if that's your cup of tea, you can check out. Somebody's got SECP 256K1. Somebody's got a Schnorr signature thing. All kinds of really, really cool stuff like that. There's something about MakerDAO's median oracle. Let's see, what is this? There's an update function called poke, receives a set of ECDSA signed values and timestamp tuples, sets the oracle's value to their median, verifies the signatures, etc., etc. Oh, okay, so it is also being deprecated, so this is more just like a tinkering kind of thing, since it obviously would never be commercially used by Maker. With something like Uniswap v4, oh, one sec. Think about Huff Runner. Yeah, oh, yeah. So the Huff Runner is something that I put together a while back. It's very similar to what we were just looking at. Let me find it real quick. Let's see. Yeah, so this is pretty much that. I did like a little bit of like syntax sugar that allows you to do this allows you to do like dot dot chaining or like method chaining, right, where you can say like dot compile, dot deploy, stuff like that, right? It also has stuff for constructor arguments if that's something you're looking for. That's also like totally valid to use. But yeah, so hopping back over to this hackathon project list real quick. So UniV4 hooks. There's actually going to be like a ton of design space for this. I mean, as there kind of already is, right? So like, you could do Oracle hooks. You could do like these like really efficient, like pretty much anything you can do with like the standard like UniV4 hook system you could do in Huff. And that's going to be really, really valuable, right? Because that's one of the like hot paths. Like if your pool has a pretty decent amount of volume in it, everybody's going to be touching that hook contract. So there's a lot of gas efficiency gains that you can get from that. Foundry cheat code macros, that would be pretty sweet. So just any kind of abstraction from within Huff that allows you to like do with some of this Foundry stuff, right? Like DevTooligan put together this thing recently about like creating like breakpoints, right, in your Huff code, where like it's like a Foundry recognized breakpoint, and so you get some like pretty cool you get some pretty cool like abstractions from things like this where you like wrap this. This next one down here, macro expansion. So this is something that I actually recommended, or that I put onto this list that I think would be really, really cool. Basically, like if you look at some of the more complicated projects, right, you're gonna have like macros defined in macros, like, or called inside of macros, right, and like oh, by the way, DevTooligan, can you drop that breakpoint link? Oh, very nice, thank you. But yeah, so sometimes you get like there's like macros inside of macros inside of macros, and it's really, really hard to like trace through the code and like reason about what's going on. And a macro is basically just taking its inner block and then just copy pastes it like anywhere that you call it, right? So it would be really, really cool if we could have this sort of tool that does like a recursive like macro expansion that goes and expands them like in place, and so that allows you to actually take a look at like what the actual bytecode is going to look like. Ideally with some kind of indentation, right? Like maybe some kind of like annotation that lets you know like um, hey, lets you know what it does, right? Like or where it's coming from. Like that would be a really really cool tool, I think. Love to see that. But yeah, of course, there's plenty of other like Huff tooling as well, right? Like there are people working on like Huff formatting, like with the Huff style guide that we that I talked about yesterday a little bit. Stack comments, maybe linters, right? Little things that can check, like I mean, I guess you'd probably need some kind of symbolic execution for this, but like you could do some kind of check to make sure that the state of the stack before each macro is correct. Something that I personally would absolutely love to see, and like if it doesn't happen, then I'm probably just gonna go and do this at some point anyway. So as far as I know, I think there's two tools out there like that right now that are like these CFGs or like control flow graphs. Um, who does it? John Becker does one in Heimdall, and then I think Plotchy does one as just like a standalone tool. But basically, what this thing does, right, is it uses symbolic execution to generate these little like chunks of code and shows you the control flow between them, right? And so that's a start. But something that would be really, really cool from that is if you did like a sort of peephole optimizer on these chunks of code, right? Peephole optimization is like very simple like bytecode simplification rules, right? It's like if you push two constant values to the stack and then add them together, you could just replace that with pushing the sum of the two, right? Like very, very simple stuff like that. And so that's actually like, even though obviously most engineers would like see that and already know like, oh yeah, we can just optimize that away. It does make for like better macros, right? So you can have these macros that are more generic, that can fit more use cases, that seem like they would be more inefficient, but with a peephole optimizer, you actually get that abstraction for free, right? So something like that I think would be pretty badass.
I created this little document here with some notes to talk about some kind of administrative things for the hackathon. Can you hear me, Jtriley?
Yeah, we got you.
So, should we just talk prize pool?
Yeah, totally. Let's do it.
This was kind of like the initial idea that I just had randomly, and then a community member suggested a flatter pay structure like this, which I think is really cool. You know, it gives it shares the wealth with more participants. What do you think, Jtriley? Curious what the chat thinks too.
Yeah, totally. So the initial prize structure, that was kind of what we were thinking. We didn't really expect there to be like a ton of signups, so we figured it would be, pretty cool if it was just like maybe 10 people showed up, right? And then we just have like a couple of those. But since then, I think we've actually crossed 100 separate signups. Now, obviously, some of these guys are going to be on teams and things like that, right? But because we do have a lot more participants, I think it would totally be fair to have this wider prize pool out to 8 there. Also, Panic, we'll jump over to the gas optimization stuff for Yule and Huff in just a moment.
Yeah.
I want
There's not
to make
much to
sure
talk
we
about
talk about
here.
that. But
Yeah. We can just go through this real quick. So yeah, unless will the projects be judged in the same way for teams of three and teams of one? Yeah, I mean they will be, frankly, right, Jtriley? I mean that's just how Huffathons work. I mean, you know, we yeah, we're not gonna change the judging based on the number of team members. Um,
yeah, totally. It's I mean, also like this is like a pretty short hackathon, so it's we're not expecting some kind of like crazy big extravagant thing, right? Like and obviously like you know. th- some hackathons won't name names, right? But some hackathons kind of have this like reputation of getting these like massive teams, and they work on them for months at a time, and then they just kind of like show up at these hackathons, right? For like for visibility, right? Like that's not what we're looking to do here, right? Like this is very much meant to be like everybody starts at the top of the hour, and based on like what you get done, like we'd love to like check it out and all that kind of stuff, right? So I do think we have a scoring sheet officially somewhere. I think we'll have to pull that back up, but it's pretty simple axes, right? Just things like how creative is the project, right? Like how like innovative is it? Like what's it doing unique? Like things like that, right? So we'll also make sure to share that with you guys as well, just to make it clear like what it is we're like the criteria we're judging from, right?
Are we going to share that with them in the next 20 minutes or so?
Yeah, let's do that. We should pull that up. I need to find that. We have, oh my God, we have so many group chats for this hackathon.
We could even
But
just
yeah,
think of it
totally.
right now. And then another thing to talk about that you just kind of touched on was about starting at right at the hour here. I mean, I think some people probably have created their repos before that time. I think, which is fine, but I think we don't want a project that you've been working on for the last 6 months and you're just kind of finishing it up or polishing it up during the hackathon. We really want this to be a new body of work. And so, like, if you are, for example, adding like a big feature to something that you've worked on or somebody else, then just try to set it up as a dependency so it's really clear. Set the base up as a dependency so it's really clear in the portion that you're working on, I would say. Um, and then, would you agree with all that, Jtriley?
Yeah, yeah, definitely.
So yeah, I mean, I mean, if the repo was created before the hour, that's fine. But let's keep all the work to the 48 hours, starting at 4 p.m. UTC, ending 4 p.m. UTC on Monday, and it's pretty open in terms of submissions, right? It could be any language. It could be in Huff, but it could also be some tooling for Huff that's written in a different language. Isn't that right, Jay Truly?
Right, yeah. So as long as it's related to Huff, obviously, like, we could have just done like only Huff contracts, but I think like the design space is a bit bigger if we also allow Huff tooling, and also, I think tooling around Huff is something that's like really, really important, right, for the future of the language. So, definitely want to like keep that open as well.
One thing I will say, is I know Jay Truly feels this way, and I do as well, is don't spend a lot of time on your UI if you're not doing a Huff thing. Like, we really, we've both had experiences where a fancy UI can really, I would say, tarnish the judging in some ways, and so your UI work is not going to be highly regarded, I should say. So let's focus on the logic, doing cool stuff, doing new innovative creative stuff, as opposed to making a shinier button.
All right. So, still looking through for that criteria. I'll dig a little deeper into that in just a moment. But yeah. So really quick, I guess Panic, if if you're down, Dev Tooling, and we can hop into a little bit about like the gas
One
optimization
last
stuff
thing.
there.
Sorry, one last thing. I
Yeah, go
just
ahead.
want to ask is, so let's say I'm a hackathon team. I finished my awesome Huff contract. I'm ready to submit it. It's like Monday morning. What do I do?
Right. So, I believe that did we already set up the form for that?
Well,
Because
we have the
is it
original application form. So, would you like to do a Google form, or another idea that came up was just like a Discord channel where it's just only for people to drop their submissions.
Yeah, I think either one would be good. Let's do. Let's keep the form open, because there may be people that aren't necessarily in this Discord. I know some people just absolutely hate Discord, and that's totally valid. So, let's make sure that form is open and good to go. We'll make sure that that's straightened out. Of course, we will have a channel for you guys to totally like share and like show your projects.
So, are you?
Get some
Hey, I'm
discussion
sorry.
going around it.
I'm
So.
sorry. Just to clarify, are you suggesting to use the original form? Because one of the problems with the original form is that, like, we made the GitHub repo optional, and some people didn't have it set up at the time, and so it would be a lot of work to kind of have people go and submit a second time, and then I don't know I don't know what you think. That's why I was thinking the Discord channel, because then we can say, okay, this is definitely a good submission versus something that came through on the form.
Yeah, totally. We can do the Discord channel as well. Like that's I think either one is good.
Awesome. All right. Well, I mean, definitely, if you haven't filled out the registration form, do that, and then as a kind of a secondary, as a backup, we'll also run the Discord channel. That sounds awesome. I'm gonna stop sharing my screen.
Cool. Um, let's see. Just create another Google form for submission. Oh yeah, I guess we could do that as well. Let's keep the primary channel as the Discord thing. I guess we can keep the forum as, you know, that a sort of thing that people that may not necessarily be in the Discord could do. I think we did require that there was at least like one representative from the team in the Discord channel as well. So we'll make sure that, you know, everybody can get in touch that way. But yeah, cool. So if there aren't necessarily anything else, I guess we could do a little bit about the Huff and Yule stuff. What do you think?
Sounds awesome.
Cool. Let me close out a bunch of tabs. Got a bunch of these open. I'm out here looking for the criteria piece, but let's go ahead and share screen. Okay. Let's see. You got my screen?
Yep.
Can you see it okay, DevToolie?
Yes.
Sweet. All right. So, yeah, obviously both of these guys are like pretty low level, right? Now there are like these sort of like macro, like macro might not be the right word, but there are these sort of like higher level like optimizations, obviously that are applicable to both, right? So these are high level things like if you have to do a loop, you know, maybe try to avoid reading from storage every single time, or try to avoid, you know, things like logging events in the loop, right? Things like that, right? Like pretty basic, straightforward stuff. But in terms of like, I guess like Yule versus Huff, right? Like a lot of where the gas overhead comes from in something like Yule is more of like the control flow, right? So that's you know, like functions and like switch statements, you know, loops, things like this, right? Like all of this is pretty much abstracted away like in Yule, right? And so with Huff, because you don't really have these like higher level constructs, you can choose how to go about this. Now, obviously, like most loops and you know, branching statements will look relatively similar, right? But there is like a little bit more like fine grained control that you can get over things like that. Obviously, like stack manipulation, because you can't really manipulate the stack in something like Yule. You know, you just do this variable assignment and the Yule compiler figures it out. But yeah, I think like there are definitely like some advantages you can get like between the two, but you know, overall, like a lot of this really boils down to like you probably have more context on like how something's supposed to behave over Yule, and so because of that, you can kind of take advantage of like different behavior, right? Like I said, the biggest thing is probably the stack scheduling, which I think yesterday's talk, there were some links you know, mentioned in there about like doing stack scheduling and doing other kinds of yeah, basically like what you want to do with this stuff, right, is like you want to learn how the compiler does these things, and then how to like improve on what the compiler's already done, right? So like I said, stack scheduling is a big one. You want to understand like how the compiler does stack scheduling, and then kind of emulate that, but like with your own amount of context that you have in there, right, to make that even better. Let's see, let me see what this says. From my thinking in Huff, we can manage stack plus memory. And Yule just memory. Yeah, exactly. Like so with something like Yule, like you still have most of the control over like the higher level stuff, but in terms of like, you know, in terms of like the actual stack itself, like that tends to be more of like something that has to be done, you know, in Huff that I don't know. Like I said, it's hard to like think of examples off the top of my head, of course, but you know, little things like, you know, duplicating values or like caching values on the stack, you know, things that like the Solidity compiler might not necessarily do, because it kind of tries to generalize a bit. You know, you can be a bit more fine-grained with that. Things like loop unrolling, right? So if you know how many times like you're going to iterate over something, you can actually just like remove that altogether and just step through. Obviously macros are a pretty big like advantage as well, right? Like in Yule, you might write like a function that gets jumped to and from a couple of times, whereas in Huff, because it's a macro, it actually just like copy paste that code like in place, right? So like your bytecode's going to be bigger, but the trade-off is that you're not going to have to be jumping back and forth between this, right? Like there's little trade-offs like that you can make as well.